Hello everyone, I am Siv Prakash, Research Scholar, Department of Electrical Engineering, ITBHO. This is the fourth assignment session for the subject of Design of Photovoltaic System, which is teaching by Professor Anil Umanand sir. This assignment, previously you read about the incidence energy on the surface of the photovoltaic system or PV panels. But what happen if you will till the surface? Then how much energy will found? Fine. And the what is effect occurs when they tilt the system. Like a surface which will this will be the zenith axis, which is normal to the plane horizontal plane. Previously a PV panel is kept like that, horizontal at the horizontal plane, and found the energy, what will be energy occur, generated on that surface. But what happen if you tilt the surface like that? So about some angle, like some angle beta, then the normal axis of the tilted surface tilted panel is like this one. Then find the energy by the normal surface of the tilted normal axis to the tilted plane. Previously you read the two coordinate system, earth centric coordinate system and local centric coordinate system. And second one, local centric coordinate system. In earth coordinate system have three plane, like a polar axis, east axis and meridional axis. Oh, this is the earth. I'll take a part of this one, define the axis, I'll take this as the insulation line, which is L, defined as L, and effect of this one on the horizontal plane is L dash, and angle of between this one is known as the declination angle, and angle between meridian line to the tight surface is known as the hour angle. And previously we will define the all surfaces like LP and LM and LE. Three surface, which is L defined by that one, LE plus LP plus medial axis insulation, polar axis insulation, and east axis insulation. E and M, you know about, written as an axis, three coordinate axis P, E, and M. Suppose line is this is the insulation L line. This one will be the delta, and this one will be the omega. E, M, and E, P replace at a 90-degree all of one. This one is the horizontal plane surface projection of L and the horizontal plane, and this is the angle between horizon that projection to the meridional axis, and E and M is replaced by 90-degree. Then in the L dash, you know about the L dash defined as L into cos L. And same thing LP defined as the sin L into sin L. Because of this one also replaced by the 90-degree horizontal plane and polar axis, horizontal axis and polar axis replaced by the 90-degree only. That's why this angle is a del, and this will be the 90 minus del. Then P axis is the Ln sin del, and Lm meridional axis, this one will be the L dash into cos of omega, and L dash is defined as the L cos del, this will be cos omega, LP, LM, and LE. This axis insulation. This will be defined as the an omega angle. Then this will be the 90 minus omega. Same thing. At place of cos omega will become sin omega. Cos del into sin omega. This will be three axes: LP, LM, and LE. This will be the Earth centric coordinate system. Same thing, but the solar panel is placed on the surface of the Earth, which is known as the local centric coordinate system. This is only the center of the Earth. This angle will be made by the center of the Earth, but panel is placed on the surface of the Earth. Then you know about this one. If you take this one is the plane surface, place on the surface of the earth, then the normal to the surface and meet to the origin of the earth is known as the zenith axis. And east axis is same as the previous east axis. It will be denoted by the capital E. This will be the tangent of the normal surface is known as the south. An angle between the meridian axis and the zenith axis is known as the phi angle and also known as the latitude angle. Phi is latitude angle. This will be the insulation line. Insulation line, zenith angle to the insulation line is known as the zenith angle. Zenith axis to the insulation line angle is known as the zenith angle. Theta z, you do not write that. Same thing you can apply a coordinate system here. Capital E. This one will be the zenith axis Z. This one will be the south axis S. Same thing occurs here also. We take this insulation line L and projection of this one on the horizontal plane L dash. Angle between them is the theta Z, and this angle south pole to the projection of the insulation line on the horizontal surface is known as the gamma. Yes. And you can find the all of component all of them, like LE. This one will be LZ. This one will be the LS. Written here L is LE plus LZ plus LS. Same thing, LS is L dash into a cos of gamma S. But this angle is the theta Z, then this angle will be 90 minus theta Z. Because of this one will be the replaced by the 90 degree horizontal axis to the Z axis, zenith axis, horizontal plane. That's why this will be the theta Z, then is 90 minus theta Z, and L dash is equal to L sine theta Z. That's why LS is the L sine theta Z into cos gamma S LE. Same thing, L dash sine gamma S L sine theta Z into sine gamma S L is Z is equal to L cos of theta Z. The two coordinate system is Earth centric coordinate system and local centric coordinate system. If you combine them, then you will find east will be same axis, polar axis is the normal to the east axis. This will be south, also normal to the, this will be the meridian axis. All are displaced by the 90 degree. This will be the zenith axis. This will be displaced by the phi angle. Okay. This is the horizon plane and this is the zenith axis. If you same figure put on that, then you will find this is zenith axis, this is definitely south axis replaced by the 90 degree to the zenith axis. That's why the south, this will be the horizon plane. A PV plate panel placed with an angle of beta, I think is the tilted angle. This will be the beta angle. All of them combined in one axis. That's why looks here. This angle is beta. Then this angle will be also beta. And this will be the normal to the surface. Normal axis. The tilted angle. You want to find the energy or insulation through the normal surface, normal axis to the plane PV panel. So how much solar radiation comes through the normal surface of the panel. That's why you want to find the ln. That's why I'm doing like that. This one. This one is angle beta. This one also different beta angle. South to Z. Zenith angle is displaced by the 90 degree. This one will be displaced by 90 degree. Then this angle will be the n will be displaced at 90 degree through the panel. That's why this angle will be also a beta because of the same difference between south and the panels and normal to the Z axis. That's why this angle will be the total angle phi. This one will be beta, and this angle is phi minus beta. We can calculate the insulation through the surfaces. If you have a Lm and if you have a Lp, then you can calculate the Lm. Lm should be written as this one is, if this one is Lm, then this angle will be phi minus beta, then Ln is the projection of Lm on the Ln is Lm into cos of phi minus beta plus Lp. Lp and Lm replaced by the 90 degree. That's why this angle will be phi minus beta. This angle will be 90 minus phi minus beta. The same thing, this will be Lp into sine phi minus beta, where is Lm is the L cos del into cos omega into cos phi minus beta. Lp is L sin del this one insulation on the tilted surface, where the beta is the tilt angle. If you want to calculate the overall energy, daily energy, then you can really integrate throughout all of things through the whole day, like sunrise to sunset. I will determine energy, tilted angle, same formula, 0 to omega SR rise. I will take it as a T as tilted n into d omega. Kilowatt radian per meter square per day. You can calculate the radian into hour by multiply by 24 by 12 by pi. Sorry. Because of a day is defined as the 180 degree at 12 hour. That's why, because of the omega is maximum 180 degree, 90 degree minus 90 degree, like that, sunrise to sunset. That's why a day defined by a 180 degree maximum thing angle. But not always they are always a 12 hour. It will be vary depending on the earth rotation. Finally defined it 2 into k. This is the solar constant, pi. Because of change, if we want to change the radian into hour, and we will multiply by 12 by pi. Pi is equal to 12 hour or 180 degree. Kilowatt per meter square per day, daily energy. You can integrate this one, we will find like 24 k into SC. K is depending on the day of our year, which day. Cos delta into cos phi minus beta. This will be cos omega. Cos integration of cos will be sine. At place of omega, it will be omega SRT. SRT is the tilted angle, tilted rise angle, sunrise angle, and tilted sunrise set angle. This will be constant. That's why omega is RT. Sine del into sine. Okay. Plus 0.003 cos 360 into n divided by 365. LS is a standard solar constant 1.37 kilowatt per meter square. This is daily energy when tilted angle. But if you want to find the sunset or sunrise angle with a tilted surface, then what at sunset this will be 0. For sunrise and sunset time, you can put the 0, then you can find ln equal to L cos omega into cos del into cos phi minus beta plus sin del into sin phi minus beta is equal to 0 for sunrise and sunset. Then you can find the cos omega SR. T is the tilted angle. We take a minus of tan phi minus beta into tan del cos of inverse of tan phi minus beta into tan del. And if non-tilted angle panel, then omega SR, you know, for this one will be a beta is equal to 0. Same thing, tan phi into tan del. Let's start the questions. The solar declination angle on the August 30, 1989. I am doing this derivation because of the question. Some of question asking related to this one. Okay. So now first is asking about the declination angle. You know about declination angle. This will be the earth will be tilted by 1 degree, sorry, 23.5 degree. On equator, the equinox plane, this is the 23.5 degree plus 25 degree. This will be minus 23.5 degree. Declination angle, the center of the earth declined by the insolation line or sun rays. This is the insolation line L. Angle between the equator plane to that insolation line is known as the declination angle. It will be depend on the day of the year. This will be the June at summer, you can say, and this will be the winter in the December. This will be the March and September. March and September, at the March and September same position, or the earth is the insolation line is take a same position on the earth. It will be the March and September. 21st, you can say, at a day 21st, it will be same line, and we make a equator plane angle will be 0 declination angle. It will be calculated by a formula. It is 23.45 sine 2 pi n minus 80 divided by of 365, wherein is the number of day. Like for January 1st, January it will be 1, and for December 31st it will be 365. But it will ask about the August 30th 1989, then find the number of day. August, it means January, start calculate from January will be 31st, 31 day. February is 28, March is 31st, 31, April it is 30, May 31, June will be 30, July will be 31, August is given as the 30 August. At 30 August will be 30. Calculate all of the 30, 31, 30, 31. Will be I think 242 days. Then put the value number of n at the place of n, the 242, and place of pi will be in a radian, and put a 180, and degree or a degree. Then calculate a del. Minus 80. It will be 8.1 degree. It means by the reclination angle you can calculate the day of the year. Second question related to the hour angle at 11 a.m. Hour angle basically this angle insulation line. This is the horizon plane. At a horizon plane, this is the hour angle. This is the meridian axis M. Hour angle vary from here to return this one to here, like that. After that, this one return will be from one position. Will change from here to here. After that, this one will be here. Meridian axis. At the meridian axis, omega angle will be 0. At to 0 angle, it means meridian axis will be defined as the noon time. That's 12 a.m. That's 12 p.m. at the noon time, meridian axis. So know about the AM PM, also defined by that only, that axis only, AM and PM. This will be the anti-meridian. This is the post meridian. It means with this angle will be changed like that from sunrise to sunset. This will be the hour angle. Hour angle change from sunset to sunrise. This will be a sunrise. Sunrise here, and it will be sunset here. That's why we will know about the sunrise angle will be negative of the sunset. Vice versa. It will be given into hour of angle at 11 a.m. At meridian axis. If your meridian axis is replaced by the 1 hour, then angle will be changed to 15 degree. For 1 hour, angle will be changed 15 degree. This will be sunrise angle. It will become sunrise like that. This will be 12 a.m. 12 p.m. 12 at noon. Before the median axis, it will be a positive of 15 degree per hour. If you take a 10 a.m., it will be at 30 degree. If you take a 9 a.m., before the 12 p.m., it will be a different of 15 degree per hour. After the meridian line, meridian axis, noon, or you can at noon, angle will be changed like 15 degree. If we talk about the 1 p.m., angle will be a minus of 15 degree. If you take this, there is the negative of this one. Here is the positive only. So this only be the omega SR, because of the omega SR is the positive angle, omega sunset is the negative angle. That's why usually like that. From here to here is will be positive angle, and this angle is be noon 12. At before 1 hour it will be minus plus plus of 15 degree. After 1 hour it will be a minus of 15 degree. That's why for 11 a.m. 11 is the before of the noon, up 1 hour before to the noon. That's why it will be angle will be 15 degree. If you talk about the 10 a.m. it will be the 30 degree, plus of 30 degree. Same thing if you talk about the 12 p.m. 2 p.m. it will be the minus of 13 degree, 30 degree. This one is for the 2 p.m. This will be the 10 a.m. the 11 p.m. a.m. This will be quarter of the 1 hour with the 45, 11:45 approx that. Next question is that at the same latitude and longitude, the air mass index at sea level is 1.5 for a place at the same latitude and longitude but above the sea level where the ambient pressure is zero point 0.8 atmosphere. The air mass index. You ask about the air mass index. Air mass index is defined the length of insulation axis to length of the zenith axis. Ambient pressure is the 0.8 of the atmospheric pressure. You can say P is equal to 0.8 P naught atmospheric. This will be the normal at ambient pressure. So you can say P by P naught it will be 0.8. Know about this only calculation. That calculation we find this one. This is the power insulation power. This will be the watt hour per meter square or kilowatt hour. This will be a formula only when the atmospheric atmospheric effect is not included. This one, but and the at that the surface of the earth, the a lot of atmospheric effect will be occurs, like air mass and clouds, everything scattering and water vapors. A lot of things will occurs affect the overall power of the solar panel. This phenomena is occur at the out of the atmosphere of the earth, like extraterrestrial and extraterrestrial plane. This one will be a formula only, and the none of the any effect I'll consider in this. If you want to consider the all of effect, like air mass effect and clearance effect, clearness index factor, a lot of things. because of the scatter of are diffused by the clouds of all of rays comes from the sun. Clouds are there, that's why the some of the rays is diffused by them, and deflect by other point to that surface is also affected. That's one. The all of thing is a different thing. This formula only for the, you can say as the ideal cases, like without of atmospheric effect of Earth. Just when this will talks about the your mass index. Like if we take this one with the Earth point, this one with the axis. Some of the Earth atmosphere also here. This one with the atmosphere of the Earth that's surrounding to Earth. We have a plate on the surface of Earth, like this one. If you take a solar panel on the surface of Earth, then this one is the zenith axis is the normal to the surface, and to the center of the Earth. This is the zenith axis. The insulation line, if you take insulation line occurs at that surface, at that point, from here this will be the insulation line. This one is meridian axis, that's why this will be phi. Meridian axis to the zenith axis, so we have phi angle. You know about this angle is insulation line to the zenith axis to the insulation line is known as the zenith angle. Touch it. Length of this one, length of this one to the length of insulation line at same point is known as the air mass index. To take this one is the L. Take this one with the one like at a unit length, because I will take as a unit length. At unit length, what effect of the insulation length to that at that point, then you can calculate the air mass index. Okay, L is equal to, you calculate this one by trigonometrics, tying 1 divided by of cos of theta z. This will be the sec theta z. But at different atmospheric pressure, this is the length of this one only. At different atmospheric pressure, this will be a length will be affected by the pressure also. This will be the standard pressure at atmospheric pressure, and this will be the ambient pressure where you place the panel, solar panel. This will be the length of this one. This will also affected by the Then question, at the some latitude and longitude, the air mass index at sea level is 1.5. Okay, see this one will be the pressure also calculate. This one is the L, the 1.5, and at the same point, at the place, the same latitude and longitude, that means the same place, but above the sea level, where the ambient pressure is 0.8 at the atmospheric pressure. This will be the P is equal to the ambient pressure to the atmospheric pressure is a 0.8 of this one. That's why P by P naught is will be 0.8. Then effective air mass you can calculate like L into P by P naught. This will be 1.5 into 0.8 will be I think 1.2, because the atmospheric pressure if this one will be same at the same point atmospheric pressure, that will be a air mass index will be a same, but a different atmospheric pressure it will be a different. Consider the daily energy incident on the last day of the year at the specific location on the 10-degree latitude line. What is the tilt factor without considering atmospheric effect? If the collector is tilted at an angle that is the same as the latitude angle. Okay, a daily energy incident on the last day of the year. It means, and you can define as the 365, and at a specific location on the 10-degree latitude angle is given phi is equal to 10 degree, and the collector is tilted at an angle that is the same as the latitude angle. It means beta is also is 10 degree, because it is given is a latitude angle same as the tilted angle. The tilt factor without considering the atmospheric pressure. Tilt factor you can say like divided by RD daily energy on the tilted surface to the daily energy on a horizontal surface or the without tilted, you can say it will be a daily energy on tilted surface to the daily energy on the horizontal plane horizontal plane surface or a non tilted surface. Daily energy on the tilted surface you will define in the, I think this will be the daily energy on the tilted surface. (24 into K LSC cos del cos phi minus beta into sin omega SRT on tilted surface. HOT, it means at non effect of the atmospheric pressure. If you include the atmospheric pressure, that will be a different thing, but the question is given without considering the atmospheric effect. This will be 24 into K divided by pi. This will be cos del into cos phi minus beta to sin of omega SRT. So we are tilted sunrise angle plus omega SRT to sin del into of sin phi minus beta. Same thing daily on horizontal plane surface. Same thing, but this will be the P beta will be 0 at horizontal plane. Up in non-tilted surface, beta will be 0. Then it will become a cos del into cos phi to sin omega SR because of the non-tilted sunrise angle plus omega SR sin del into sin phi minus beta. You can divide both to take a ratio of this one. It will be a tilted tilt factor. This will be the cancel out. We will have cos del to cos phi minus beta to sin omega SRT into sin del to sin phi minus beta. Omega SR sin del into sin phi minus beta. You can common, this will be cos del into cos phi minus beta sorry, this will be the sin phi only. Can take cos del into cos phi. This will be sin omega SRT plus omega SRT. So this will be sin del divided by cos del. It will be a tan del into this will be a tan phi minus beta to tan del into tan phi. This cos del cancel out. You can calculate tilt angle from here. Cos of phi minus beta divided by of cos beta. Phi is given 10 degree latitude angle, same as the beta, and del is not given. You can calculate del by a formula 23.45 sine of 2 pi into n minus 80 divided by of 365. N is the number of day, but number of day is given as the last day of the year. It means 365. 365. Then you can calculate del angle from here. Put a value pi at pi, it will be 20 degree, pi in a degree. It will be a 23 minus of 23.01 degree. And for omega SR is equal to tan inverse cos inverse of minus 10 pi into 10 del omega SRT tan cos inverse of minus 10 pi minus beta into 10 del. This will be that a tilted angle, but sometimes it will be a greater than omega SR, so that to take omega SRT is the minimum of this one. Minimum of this one is the omega SRT only. Sometimes this angle is greater than this angle because of the calculation, a mathematical calculation. But in the real thing, at the tilted surface, the sunrise angle is not more than the without its tilted angle. That's why it will be a minimum of this one will be taken. Phi is 10 degree, beta is also 10 degree. If you take this one with 10 degree, this one 10 degree, tan 0, it means all of thing is 0, cos inverse 0 is 90 degree. This will be 10 degree, del is equal to minus of 23.08 degree. This will be 85.7 degree. Take this one as a omega RT also. Calculate in radian because of you have required of this one. It will 1.495 in radian. Then calculate RD value. Cos phi minus beta is be 0. Cos 0 means 1. Phi and beta is be same. This will be 0. Then all are part of 0 here. All part is 0. Cos phi is 10 degree. Then take a this will be cos 0 divided by your cos 10. Omega SRT omega SRT is same as omega SR, and sine this one only this will be all 0 because of that phi minus beta is 0, and sine 10 divided by of sine 10 plus, oh sorry, this will not, omega SRT is 85.7 degree. 0.7 degree plus this will be 1.495 because of the omega star should be put in radian only, don't be put in angle only put in here. 10 sine cross 10 del is equal to minus of 23.01 degree into 10 5, 5 same as 10 10. Calculate this one, and we will get the tilt factor. This will find 1.144. This will be the tilt factor. Next question is, a solar collector is placed at a specific location on the Tropic of Cancer. What is the sunrise hour angle? Sunrise hour angle on summer solstice. Solstice, if the collector is tilted at an angle that is same as the latitude angle. No, there is a 3 point on the earth. There is a Tropic of Cancer. This line is the tropic of Capricorn. Capricorn. This is the equator line. Say that the specific location on the Tropic of Cancer. Tropic was, it means that this angle. This angle will be a 23.5 degree. This will be the delta angle is given. Del is equal to 23.5 degree. Okay. Next is ask about the what is the sunrise hour angle. Tilted an angle with tilted omega is RT is at an angle that is same as the latitude angle. Latitude angle phi is a 23.45. Phi defined as the latitude 2 pi n minus 80 divided by 360. Sorry. This one with the delta angle.
Delta no shit.
Okay, sorry. Not with the phi. So this will be location is given a specific location on the topic of the cancer. This is not sorry. This is not define the delta angle. This will define as the phi angle. It will be the latitude angle because I was given a specific location on the tropic of the cancer. On the tropic of the cancer, that's why this will be the phi will can calculate the 23.5 degree is the phi angle, latitude angle because this will be defined as the location. Second thing is given is the what is the sunrise hour angle on the summer solstice. This will be the number of days with 172. By this one, you can calculate the angle of del. This will be the angle defined here. Is the tilt angle. Oh, sorry, declination angle delta. And tilt angle is same as the latitude angle. That's why this will be the same as beta. Then you can calculate del angle 23.45 sine 2 pi, where n is the 172 minus half 80 divided by 360. Okay, this will be the take a 180 degree. 23.44 degree is the delta angle, and phi is the phi is equal to beta is equal to 23.5. Ask about the sunrise hour angle with a tilted surface. Then calculate the both of this one, omega SR and omega SR B with tilted. After that, find omega SRT is the minimum of a omega SR and omega SRB. This will be the cos inverse of minus tan phi into tan del. This will be the cos inverse of minus tan phi minus of beta into tan del. Phi minus beta, it will be 0 because of the same thing is given latitude angle same as the tilted angle. It's all part of 0, and this will be a 90 degree. And omega SR you can calculate tan phi is equal to 23.5. It will be the 100.8 degree. Then minimum of this one is the 90 degree. Then omega SRT is a 90 degree. It will be the 1.57 in radian. Okay, in which location altitude it is the possible to have a day without sunrise? Know about the earth. Earth is tilted by at angle of 23.5 degree. So this will be center of this one. This will be the zenith axis. This is latitude meridian to the zenith is will be phi. This is the pole of this one. This will be vary from this one to there to there, here to there. That's why sunlight as occurs from here. It will be like that. This one will be rotation. At that point, this will be the sun. This will not a sunrise. At that point, this will be a negative portion of this one. Latitude angle, it will be negative, but goes there, then it will find the minus of 66.5 because of 90 degree. This will be 90 degree minus of 90 degree. Then the sunset is occurs at the minus of 23 degree beyond this one. It means this will be a 90 degree minus of 23.5 degree. This will be the without sunrise. It will be 18 of course 66.5 degree. It will be minus 66.5 degree to the minus of 90 degree. That location it will be not a sunrise up. Sun is not rise at that position, that location. Minus 65.5 to minus of 90 degree. This will be a 0 degree, 23.5 degree. You can see this will be a sunrise because of this will be upper side of this one, Earth. This is the bottom is the negative of this one. A vertical pole of length 4 meter is placed on the particular point on Earth. Okay. This will be 4 meter. If the length of the shadow of this pole is 2 meter, then air mass index. Suppose this will be the sun. This will be 2 meter. This is the horizon plane. You can take this is the horizon plane. Then normal to this one is this is the zenith angle, zenith axis. You know about the air mass index. The atmosphere here surrounding to this one is the earth. This is a point location where the panel is placed. This will be the sun. Zenith axis. This length to this length. So take this one A to B, and A by B is known as the air mass index. Previously I say like this one I've taken 1, this one taken as I taken the 1, then AM I will define as the L by 1 by sorry, L is defined 1 by a cos of theta z. This will be a theta z. And also you can define the length of the zenith axis to the length of the sun insolation line. It means that this length to this length is known as the air mass index without taking the atmospheric pressure, because of there is not defined atmospheric pressure. That's why we leave this one. If you take this as sunlight, this will be the zenith axis length is given as 4 meter. Then what is this thing? This will be the triangle There is a 4 square. And this will 4 square plus up 2 square. And root of 20. Okay. I think you can say this length will be same as this length at that point. Then you can say air mass index is 4 divided by f root of 20 of this length and this length. 0.89. So sorry, you can calculate the angle of this one also. By angle you can calculate a cos of theta z. This will be theta z. Let's calculate this angle. Tan theta is 4 by 2. Theta is equal to 63.43.
Sir, we can calculate zenith angle now, sir.
Yes, yes.
theta z, that will be tan theta z will be 2 by 4.
The zenith angle is this one, na?
Yeah, zenith angle is this one, no sir. So theta z will be 1 by 2, and phi z, that is zenith angle, will be 26.56. And if you substitute in this equation, am is equal to, that is 1
Yeah,
by,
yeah, yeah. This one is theta. It will be theta z is will be a minus of this one. 90 minus of 63.43.
okay, yeah. So the other way also we can do, no sir.
Yeah, yeah. Okay. It will be, I think it's 26.57 degree. Then you can apply
Uh,
air mass index 1 by a cos of 26.57.
we will get 1.12.
1.118 or approx 1.1. This will be not correct, I think. Okay, we will calculate from this one. At sunset and sunrise, the air mass index at sunset and sunshine, theta jet will be 0, I think. Oh, sorry, 90 degree. Because of this one, if you have a local concentric coordinate system, we have a zenith axis, and have a south axis. So in insulation, this will be the zenith axis, zenith angle. It will vary from 0 to 19 and 0 to minus 90. Then air mass index 1 by cos of 90 degree. It will become infinity. But in the practical cases, it will be not infinity. It will be maximum will be taken as the 38 only. Because of this will define length by length also, length of the zenith axis and to the length of the insulation axis to the length of the zenith axis, length of the insulation axis to the length of the zenith axis. So length will not be infinity at that point. That's why it will take a maximum 38 at sunset and sunrise. It will not going to the infinity. By formula we can say like a theta is to 90 degree, then air, air mass index will be infinity, but it will not infinity, but it will maximum 38 only, approx to 90 degree. It will not a pure 90 degree. If you take a 38, then you can calculate as it will be approx 88.5 degree. The albedo is the term used. Albedo is the reflected reflected rays of the sun by some object and scattered on the plate of the panel. Suppose you have a ground surface like that, and we place a plate panel here at some angle, tilted angle like this one, tilt angle of a beta. This will be a PV panel. This is atmospheric condition. Sunlight, this will be the normal to surface. This will be a direct sunlight. But some of the rays coming from here also, and after that it will be reflect to the surface of the panel. Then this reflected rays will known as the albedo. This is the three part of power, energy, daily energy. If you want to calculate this one, first part is the direct from the sunlight, second is from the reflected by albedo, and third is the diffusion by the clouds. This one is some clouds. By the cloud deflection, some of the rays occurs passing through the cloud also. This will be the diffused rays. That's why a total energy at tilted surface, this will be tilted surface. It will be if this one is the normal surface, horizontal surface, then this will be not occurs. Albedo it will be 0. This will be coming from a direct axis plus of diffusion plus of reflected. Then the albedo is the reflected part. The option is given the direct component of incident energy. No, direct is the sun other thing. The ground reflected component of the incident energy. Yeah, this will be the ground reflected by some mountain or some other thing. The diffused component of incident, this is from only clouds or air's moisture on the environmental of the earth, atmosphere of the algebraic sum of direct diffusion and ground reflected component. This will be total energy. This is the diffusion by the clouds. So this is the reflected is known as the albedo. If the clearness index at the location is 0.1, then the ratio of energy incident on flat plate collector without atmosphere to that with atmosphere will be. Clearness index is KT is defined as the without atmospheric effect divided by a atmospheric effect. Energy without atmospheric effect to the atmospheric effect. This will give a 0.1. And ask about the incident energy flat plate collected without atmospheric to the atmospheric. Oh, sorry, this will be like written and ask about the same thing. Ask, I think opposite of this one. It will be 10. By this one, the total energy H80 it means the A with atmospheric effect, and T means a tilted panel. the sum of the diffusion and other thing. Direct axis plus diffusion plus reflector. I have calculated the RD is the reflector. This one is the tilt factor. Know about the tilt factor. I have calculated is a cos phi minus beta divided by your cos phi into sine omega SRT plus some omega SRT into 10 phi minus beta into 10 del divided by f sine omega SR plus of omega SR into 10 phi into 10 del. This is the tilt angle and tilt the panel. Then what is the effect of this one? And second thing occurs is the second factor is the clearance factor. This is the clearness. This is KT is known as the clearness index. It will be defined as the daily energy incident on horizontal plate with atmospheric phase condition. Pair to the daily energy incident plate. This will be with, this will be without atmosphere. It means a KT is equal to with atmospheric without atmosphere effect. And KT is measured by the pyrometer. Pyrometer, you can measure the KT. Or you can measure the overall HA with atmospheric. What is the total energy on one day, and you can divide by the standard without atmospheric. This will be the standard. You can say, then you can find the KT. The total energy affected by the two factor KT and RD. That's why if you want to calculate the overall energy with HE means atmospheric effect with a tilted angle also, this will be defined as the RD is the tilted factor, KT is the clearness, clearness index, and this will be the overall without atmospheric and without tilted surface. You can calculate the out of thing from here also. You can separate this one by some thing. Okay, let's next question is then the ratio of energy incidence. Same thing we will ask about the This will be given KT HA divided by FHO. It will be 0.1. Then not say anything. You ask the reverse of this one. I think this will be the same question. Sorry. Next question is given. What is the length of the day in hours? If the if a declination angle is minus 20 degree, length of the day in hours. Declination angle, it means delta is equal to minus of 20 degree. Latitude angle formed by the zenith axis and the meridional axis is 30 degree. It means phi is given 30 degree. Angle of tilted horizon plane is 10 degree. It means beta is equal to 10 degree. Let's ask about the length of the day in hour. Length of day you can calculate from the hour angle. Sunset to the sunrise to the sunset angle. If you add both this one, sunset sunrise to sunset overall angle, you can find. If you find this one, then you will get the total overall hours of a day. So for a calculation of this one, calculate the overall, calculate the angle of hour angle. This will have two formulas: omega SR beta. This will be the cos inverse minus of tan phi tan del. Second will be the cos inverse of minus of tan phi minus beta into tan del. This will with tilted. This one is without tilted. Then omega sir, we will calculate this one. Phi is given 30 degree. Del is given minus of 20 degree. This angle is 77.86 degree. And second angle is 89.27 degree. This will be we can calculate with a tilted surface. SRT is equal to minimum of this one omega SR into omega SR beta. It will be a 77.86 degree. Then what is we say the omega SST? This will be the sunrise angle. Sunset angle, it will be a minus of 77.86 is the sunset angle. Total day angle, point 0.86 minus plus of 77.86. 155.72 degrees. Know about maximum. Maximum is 180 degree. You know about the 180 degree. It will be equal to the 12 hour update. Then what will be at 155.2 degree. It will be 12 divided by a 180 degree into of 155.7 degree. 10.38 degree. Sorry, 10.38 hours. A day with a 10.38 hours. So I think last question. What is the air mass index for zenith angle found by zenith axis and insulation line is 30 degree? You can do L is equal to 1 by f cos of 30 degree 1.15. Okay, really simple. Okay everyone, I am stopping here.